Welcome back everyone. So in this video, we're going to continue this calculus exercise derivatives. So this is the part 3. All right. So without further ado, let's begin. So in this first problem, we're asked to find a derivative of 6x times sine x times cosine x. All right. I just said times because all the terms are combined. So if all the terms are combined, obviously what comes in our head if we're going to find a derivative of it is by using product rule. Because overall, these terms are not separated by the operations, specifically addition or subtraction. All right. So either of the two, as long as it makes them separated, we can derive each of these terms. That's it. But however, three of them are combined. So what we're going to use here is product rule, all right? So if you want to do product rule directly, then let me give you some advice. All right, you have UDV plus VDU, all right? So if your U is 6x, because that's what we usually do, right? Get the first term as your U, right, usually, and then your V would be the second term. However, we have the third term or the other function, all right? So just simply get the rest of it, all right? Get the rest of it. You can do another arrangement such as like we have 6x right, times sine x and then you have v as your cosine x. You can do this one, but you observe like in this particular arrangements that I made, observe that in letter u you have only one term, then the rest you have two terms. On to the second arrangement, your u has two terms and the other one is only one term or one function. So that means only one function is given to a particular letter, and then the rest of it will be substituted with the second letter. All right. So if you're going to find the derivative for these two, all right, use product rule. But instead of using u and v, use different letters to avoid conflicts or confusion. All right. So yeah, product rule is the thing that what we're going to do. But for me, before I do it directly, I have to simplify it first. And why do I need to simplify it? Because it reminds me of something. So there's this type of equation. 2 times sine x times cosine x is equals to sine of 2x. So this equation actually is one of the double angled identities, all right, located from the lessons in trigonometry. So, meaning 2 sine x cosine x is equivalent to sine of 2x. Can I have 2 sine x cosine x in this particular problem? Yes, I can have it in my given, all right? But the question is how? How can we do that? So 6x is divisible by 2, right? So can I factor out 6x by 2? The answer is yes. Because overall, 6x divided by 2 is 3x. Yeah. So I can factor out 6x by 2. So to rewrite it this way, I will have, let me put a notation of the derivative. So I will have 3x times 2 times sine x times cosine x. And yes, that's it. That's what we have. All right. So if yes, I have 2 sine x cosine x, but 2 sine x cosine x is equal to sine of 2x. Therefore, I can substitute this one just to replace these whole terms combined. So this would be 3x times sine of 2x. There we go. So if that's the case, then we're going to use product rule already. All right, because overall in this case you have the first term and then you have the second term combined. So you have 3x and sine of 2x. So yes, this is already the simplified what do you call this one? Simplified given. So still, both of them are combined. So we're going to use product rule. So this would be u times dv plus v times du. So your u is equals to 3x. So now let's get the derivative of 3x, or basically the derivative of your u. So by getting the derivative of 3x, just simply remove the variable. Because if you ever see this type of a number or coefficient, and then you have a variable here, which is its exponent is equal to 1, just remove the variable and just copy the coefficient. So you have 3, that's it. So next is you have v. Your v here is sine of 2x, right? So since you have another terms or function given inside of your sine function, therefore what we're going to do here is chain rule. All right. So I have two methods or two approaches I can do. The first approach is by algebraic substitution, and the other is just direct approach. All right. So let's do the first method or first approach, which is algebraic substitution, which is usually used to find the chain rule. So since the inner function or the inner function is 2x, therefore I'm going to substitute with a letter. Instead of u and v, I will have z. I will let z be 2x. All right. So since my z is equals to 2x, therefore this is like sine z already. And now let's get the derivative of my z. So the derivative of my z, or the derivative of 2x, is just the same as how I get the derivative of 3x. So just remove the variable and copy the coefficient. So you'll have 2. So let's now get the derivative of sine z. So to get the derivative of sine z, sine is equals to, the derivative of sine is equals to cosine, right, z. And don't forget your dc, all right? So you'll have here is cosine of 2x times 2. Therefore, you have 2 times cosine of 2x. There you go, all right? So that's the first method, just basically algebraic substitution because you have z, yeah. But if you want to do it in a direct way, or just derive it directly, yeah, you can do that. All right, you can do that. So, right, you have sine of 2x, right? Sine of 2x. Okay. So the summarized steps of chain rules is basically derive first the outer part, then derive the inner parts. All right. So basically, derive the outer, then to the inner part, then to the inner part, then to the inner part. All right. So since you have the outer part and then you have the innermost part, so for the first step here is derive the outer part. All right. So what's the derivative of sine? So the derivative of sine is still cosine. Cosine of, copy the input, 2x times, now derive the innermost part, basically the inside part. What's the derivative of the inside? 2. So you have 2 times cosine of 2x. Basically, guys, to get your chain rule, derive the outer part, then derive the inner part. All right, so that's it. So now let's substitute. So you have your u as your 3x times your dv, which is 2 times cosine of 2x, plus my v here, that would be like sine of 2x, and then my du, I will have as 3. So I will have 6x times cosine of 2x plus 3 times sine of 2x. So this could be my final answer, all right? But I can simplify this one. Okay, so as you can see in this expression, you have two terms. Yes, exactly. You have two terms being separated by an addition separation, but we have 6x and 3. So this two terms specifically are both divisible by 3. So if you're going to divide 6x by 3, you'll have 2x. If you're going to divide 3 by itself, you will have 1. So therefore, basically the GCF, okay, the GCF of this expression is 3. So, excuse me, I can factor out this whole expression by 3. So I'll have 3 times 2x times cosine of 2x plus sine of 2x. And that is my final answer. All right. Next. So in the second problem, we're asked to find the derivative of x times ln of x plus ln of x squared minus 3x plus 3. So the first term here, it's so obvious that these two subterms are combined. So obviously what we're going to do here is product rule. But for this case, on the second term, we're not going to do product rule here. Rather, what we're going to do here is chain rule. Because overall, there's another function given inside of your natural logarithmic function. But before we begin, let's introduce ourselves. What is the derivative of ln of x? So the derivative of ln of x is equal to 1 over x. All right, it's 1 over x. Okay. But if ever, like for example, we have an inner function given, which is obviously what we're going to use is chain rule. So in this case, you'll have, okay, let that be inner function as u or different letter if you like to put z or a, that's what you like. All right. So you will have 1 over u times du. That's it. Basically, the chain rule version of the derivative of ln of x. All right. For this second term. All right. So remember this formula. Okay. So let's go. In this first term, you have x times ln of x. So it seems like you have two terms combined. So therefore, what we're going to use here is product rule. All right, product rule. So in this case, yes, you're going to use u dv plus v du. All right. So let u be x, and let's get the derivative of your u. Just remove the x here, and you'll get the answer. So you have 1. Basically, guys, if you're going to find the derivative of this type of term, like you have a variable, all right, you have a variable, and then the variable has an exponent which is equal to 1, or just basically, yeah, like that, just simple x, not x squared, not x cubed, or x raised to negative 1, just simple x. So just remove the x just to get that derivative of it. All right, just like what I did on the previous problem here. If you want to find the derivative of 3x and you have x as your given only, like literally x, so just remove the variable and copy the number, which is 3. So there you go. And next we have your v. Your v here is ln of x. So by getting the derivative of your v, you have 1 over x. There you go. So let's do it directly. All right. So you have your u, which is your x, times dv, 1 over x, plus v is ln of x, times du is 1. So by multiplying together, this x times 1 over x, this is just simply 1, because x times 1 over x is just the same as x divided by x. So you have 1. Or what I just did here is just basically I just cancel out x, right? Since I have x here and then I have x in the denominator, I can cancel them out. So I have 1 plus 1 times ln of x is just ln of x. There you go. All right. And now last but not the least, let's go focus to the second term. The second term here, all right. Okay. Since we have an inner function, we can do 2 methods for this one. Number 1 is just simply algebraic substitution, and the other one is just direct differentiation. So the first method just basically substitutes. All right. So the inner function I will substitute as letter z. So let z as x squared minus 3x plus 3. And to get the derivative of your z, you will have 2x minus 3. All right. So since z is equals to this particular trinomial, so I will have the derivative of ln of z. So let's get the derivative of ln of z. The derivative of ln of z is just 1 over z, then times, don't forget its partner, dz. So you will have your final answer. You'll have x squared minus 3x plus 3 times your dz, which is 2x minus 3. There you go. So therefore, you have 2x minus 3, which is me, all over x squared minus 3x plus 3. So therefore, I have my final answer for the second term, 2x minus 3 all over x squared minus 3x plus 3. So yeah, that's just my final answer. All right, let me complete my solution here. What's this again? I will have 1z times dz. Then I will have 1 half 1 over x squared minus 3x plus 3 times 2x minus 3. Forgive me, guys. I'm just completing my solution here so that the other viewers may at least, how do you call this one? It's like basically to avoid confusion, or yeah, you know what I mean. Basically, I'm just going to fill in the blanks, like what happened to the solution and how does this happen. All right. So yeah, next, okay, we're asked to find the derivative of pi times e raised to x. Right. So e raised to x is an exponential function. Don't get me wrong, it's an exponential function. So let's have a recall. All right. So let's go find the derivative of e raised to x. So e raised to x is just simply as e raised to x. No changes as well. There's no changes. It's just e raised to x. Wait, let me rewrite it. There you go. It's just simply as e raised to x. Okay. And if, yeah, let's find the chain rule version of this exponential function. If ever there would be a given function inside of your x, like for example, e raised to x squared minus x and such. So basically, there's a given function inside of your exponential function. So let that be u. So the derivative for that would be like e raised to u times du. There you go. All right. Basically, the chain rule version of it. All right. So that's it. Okay. So, all right. What can I do here? Obviously, what I'm going to do here is just basically product rule. Well, yes, because overall you have two terms combined. Sure, why not, right? But for me, I'm not gonna do product rule. Rather, I'm going to do is constant rule of differentiation, right? Okay. So why? Why is it constant rule of differentiation? If you guys recall that, okay, let's just say you have a constant times a particular function. So basically copy the constant and then get the, hold on, let me erase this one. Get the derivative of a function. All right, basically don't touch the constant. It's like, how do you get the derivative of 4x squared? So this is just like copy the constant, then derive x squared. So bring down the exponent, copy the variable, and subtract the exponent by 1. So you'll have 8x. So that's it. So I'm going to use this rule, all right? Basically, I'm just going to copy the constant. And here's the question. Why is it that pi is a constant? Pi number or pi is an irrational number, but it is still a real and constant number, all right? Because if you want to know, pi is equivalent to 3.14, etc., etc., and many decimal values that you will see, all right? So if you recall in the recent news, if I remember correctly, is that like the the decimal value of 3.14, it reaches trillionth value like recently. But however, it is still in a continuous, what do you call this one? Continuous process, or in a continuous existing numbers to have in a decimal values, meaning it is non-stop, right? So it's like infinity. The decimal values will reach so on and so forth, right? And recently, if I remember correctly, it reaches trillionth value. So imagine, like you have, yeah, a number 3.14, blah 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 blah, and then it reaches a trillionth decimal value. So modify it. Like, can we do that here? You can't, right? So instead of like using 3.14 and so on and so forth, they use pi as a symbol or representation for this irrational number. It's called irrational because the decimal values are and I'm sorry, the decimal values of this particular constant number basically are continuous. It's not gonna stop. Recently, I already told you that it reaches trillion value. What more in the future? Maybe it reaches more than trillion value, right? So therefore, pi is still considered as constant. Forgive my grammar, all right? So if that's the case, okay, you're just going to copy pi times, what is the derivative of e raised to x? It's just still the same, e raised to x. Therefore, the answer for that is pi times e raised to x. All right, there we go. Next. For this one, all right, so first things first, you have e raised to 4x. So basically, you have 4x as a given or input for your exponential function. So that means we have 4x as an inner function for this exponential function. Therefore, what we're going to do is chain rule. All right. And this two, what we're going to do is, excuse me, product rule. However, in this case, I can do it in a simplified version of it. Like basically, I can simplify this too. Let's have a short recall. So cosecant x is equal to 1 over sine x, right? One of the trigonometric identities. So I can simplify this one. So if cosecant x is equals to 1 over sine x, therefore I'll have e raised to 4x plus 1 over sine x times cosine x. That's it. And let's combine 1 over sine x times cosine x. So you have e raised to 4x plus cosine x over sine x. So if ever you have cosine x over sine x, all right, this is just the same as cotangent x. Recall that cosine x over sine x is equal to cotangent of x. There you go. So in this case, I can substitute this one, all right, this particularly cosine x plus sine x, all right, as cotangent x. There we go. And now let's get the derivative for this expression. First, you have e raised to 4x. So e raised to 4x, all right? So since you have 4x as an input for your e, so therefore what we're going to use here as chain rule. So I will let u be 4x. And the derivative for that, again, just remove the x. So you have 4. So you have the derivative of e raised to u. That's it. All right. So e raised to u. So the derivative of e raised to u is e raised to u, the same, but don't forget the partner of it, du. So you have e raised to 4x times the du 4. Therefore, you have 4 times e raised to 4x. So you have 4 times e raised to 4x. So yes, what I just did here is algebraic substitution. But can you do it directly? Yes, I can do it directly. All right. So since I have e raised to 4x, so basically derive the outer, then the inner. So you have e raised to 4x, right? So the outer part here is your e. What's the derivative of your e? It's still the same. So the derivative for that is still e. Okay, again, copy the input 4x. Then times the derivative of the inner part, which is your 4x. So what's the derivative of 4x? Just 4. So therefore, you have 4 times e raised to 4x. Basically, derive first the outer, then derive the inner, and then combine them together. You have 4 times e raised to 4x. Next, let's find the derivative of cotangent x. And I don't think that um, you guys recall or remember this one. So in case, let's find the derivative of cotangent x. If you want to find the derivative of cotangent x, this is equals to negative cosecant squared of x. So in this case, you will have negative cosecant squared of x. All right. So your final answer here is 4 times e raised to 4x minus cosecant squared of x. You can have that as your answer, or you can simplify it. All right. Recall that cosecant x is equals to 1 over sine x. So to make things even more simplified, this will become 1 over sine squared of x. That's it. Right? That's it. That's my final answer. All right. So basically, guys, yeah, that's it. In here, in raised to 4, e raised to 4x, I already introduced you to two methods. The first one is basically algebraic substitution, and then the other, right? The other is direct approach of finding the derivative of this particular function. And I think I forgot something. Hold on. Wait, hold on. This one. Right? I didn't do this directly, right? Like, how do you get the derivative for this one without using algebraic substitution? I can do that, right? You have ln of x squared minus 3x plus 3, right? So let's do it directly. Can wait, hold on. Let's do it directly here. So first and foremost, again, the summarized steps of getting the derivative via chain rule is you have to derive the outer part first, then derive the inner part. So the outer part here is your ln. So what's the derivative of your ln? So this is 1 over, copy the input, so you have x squared minus 3x plus 3. This is 3x, guys, forgive me. Then times, what's the derivative of your inner part? So you have 2x minus 3. So therefore, you have this one as your answer. And then combining it together, you have this one already as your final answer. So that's it, guys. All right. Sorry if I forgot it. Okay. And same thing goes in here to e raised to 4x. All right. Forgive me if the way how I say it's like in a rush. All right. And I just say I already said it in a simple way, but then I make it more complicated. Anyways, let's proceed. This one may seem intimidating because overall you have 5e, and then the input of your e is another e raised to a cubic function. And then this inner e has an exponent of this function. So it's kind of a bit confusing. So let me rewrite it this way, right? Let me separate it. So this is 5 times e, all right, raised to e raised to x cubed plus 4x squared minus x minus 1. There we go. See? So the exponent of the outer e is this one, right? And then in that particular exponent you have e, all right? And then that inner e or that second e, all right, has an exponent of this cubic function. So it's like, yeah, it's like you have a outer function, then you have the inner function, then you have the innermost function. So what we're going to do here is chain rule, guys, because As you can see, all right, this is one of the examples of composite functions. All right, you have a given function here for that p, and then this whole function is an input for this particular function. All right, so let's do it into methods: algebraic substitution and direct approach. All right, so let's do it in substitutional way. All right, or yeah, basically substitution. All right, so let's observe first for your outer e. All right, and this is your exponent. All right, or your input, and the input is e raised to a cubic function. So I will let u be e raised to a cubic function, x cubed plus 4x squared minus x minus 1. There you go. All right, that is your u. So if you want to rewrite it this way, all right, this would be rewritten as 5 times e raised to u. That's it. All right. And now let's get your du, or the derivative of your u. But the problem here is that if you're going to get the derivative of your u, you're going to use chain rule again, because overall, the input of your given e here has a function here. Basically, the input of your e is a cubic function. Therefore, this is going to be different, right? So you're going to use chain rule again. So this one, I'm going to substitute this as v. So I will let v as x cubed plus 4x squared minus x minus 1. And then let's get the derivative of your v, because this one is, I think, is already simplified. Or let's just say, yeah, there's like the only way for you to derive this one is just basically find the derivative of each of these terms. So let's derive it one by one. So to get the derivative for this one, just simply bring down the exponent, copy the variable, and subtract its exponent by 1, plus, same thing goes on here for the second term, copy the constant or the coefficient, all right, times, bring down the exponent, copy the variable, and then subtract its exponent by 1, all right, minus, since you have negative x, again, if you're going to get a derivative for it, just remove the x and copy the numbers. You have negative 1, plus your negative 1 here, the constant term, the derivative for that one is 0. So therefore, you have 3x squared plus 8x minus 1. That's it. So that is my dv. So since your v is equals to your cubic function, I would rather not say the whole terms because it's kind of a bit long. So therefore, this is what? E raised to v. So can we get du? All right, du. Well, yes, we can. So now let's get the derivative of your u. So what is the derivative of e raised to v? E raised to v is, yeah, still the same. The derivative of e raised to v is just e raised to v, but don't forget its partner dv. And now let's substitute. So this would be e raised to x cubed plus 4x squared minus x minus 1. All right. Times your dv, you have 3x squared plus 8x minus 1. There you go. That's it. So now let's get the derivative of 5 times e raised to u. 5 is just a coefficient, or basically a constant number, if that's what you want to hear. So we're just going to leave it be. Don't touch this one. Overall, by the definition of constant rule of differentiation, okay, if you have a constant and then you have a function specifically, just copy the function. That's it. So meaning, leave it be. Don't touch this one. Now let's get the derivative of e raised to u. The derivative of e raised to u is still the same, e raised to u times du. So now let's substitute. So you have 5 times e raised to your u. Your u here is e raised to a cubic function. All right, times your du, which is this one. So you have e raised to x cubed plus 4x squared minus x minus 1, which is your cubic function, then times the trinomial, which is the derivative of your v. So this is 3x squared plus 8x minus 1. Basically, the derivative of your cubic function. All right. So I will put this trinomial All right, beside with 5 and e. So I will have 5 times 3x squared plus 8x minus 1. Then I will have the rest is e. So since my e and the second e are the same, so can I just basically copy them as a whole and then going to add all the exponents? Can we do that? What I mean is that, like, since you have e, right, you have your e and then your e here, which is, yeah, they're both the same. Okay, the base are just the same, but the exponents given are not the same. So can we combine the exponents and have only one e as your base? The answer is yes. For example, if you still guys don't get it, forgive me. This is how I explain or communicate it in a way. So for example, if I have x times x raised to y, so they have the same base. Basically, you have x and x, all right? But their exponents is not the same. So x, this is the same as x raised to 1. So can I just like, copy the base, have them like as a whole, then add these two exponents here? The answer is yes. So this will be x raised to 1 plus y. That's it, guys. Right? That's it. Okay, so another example, if I have y squared times y raised to x, this is just the same as y raised to 2 plus x. So that's it, right? So since we have e and e, which is both of them have the same base, so I can actually add their exponents. No matter how the same or different they I'm going to combine them both because the bases there are the same. And then exponents, and not the same, but I can still combine them because of their bases. By combining them, I'm going to add them. So I'll have e raised to x cubed plus 4x squared minus x minus 1 plus x cubed plus 4x squared minus x minus 1. There we go. All right. So that's it, guys. That's my final answer. All right. Basically, what I just did here again and then again, if you still don't get it, basically, since I have e as the same base and then they have an exponents, so I'm just going to copy e, which is their base, and then add the exponents. That's it. All right. So that's the first method, algebraic substitution. You can do it directly, to be honest. You can do it directly, right? So as long as you know the summarized steps of the chain rule, I think you can handle it by your own. So this wait, there you go. E raised to a cubic function. So this one, hold on, I'll have this. Oops, hold on. Let me erase. There you go. That's it. All right. So what I'm going to do here is basically, yeah, direct differentiation, right? That's the second method. So what is the derivative of 5 times e raised to a cubic function? So your 5 here is a constant, so don't touch it. So you have 5. Now let's proceed to your e. So your e raised to a cubic function. So again, the summary steps of the chain rules just basically derive the outer, then derive the inner part. So what is the derivative of the outer part? That's the first step. The derivative of the outer part is just the same. So this is just e raised to, copy the input, e raised to the cubic function. All right, that's it. Times, here is the inner part, which is your e. All right, so what's the derivative of your inner part? It's still the same. All right, it's still e raised to x raised to 3 plus 4x squared minus x minus 1 times the derivative of the inner part. So you have 3x squared, all right, plus 8x minus 1. There you go. See, that's actually much more convenient, all right? And now just combine them. You have 5 times 3x squared plus 8x minus 1. And then here, since you have e, both of them are the same base. Exponents uh, are different, but you can add them because of their base. So you have e raised to, all right, e raised to the cubic function. There you go. Plus the exponent here, which is x cubed plus 4x squared minus x minus 1. That's it. So you see, you have the same base, e and e. And then add the exponents, and you have this one as a whole. So that is my final answer. All right, that's it. And I think this is the last problem. So 5e raised to sine squared x plus cosine squared x plus ln of e raised to x. So, all right, so the input of your e, which is sine squared x plus cosine squared x, all right, so obviously what we're going to do here is what? Chain rule, because overall you have sine squared x plus cosine squared x, right? Especially for this one, you have a logarithmic function, and then inside of your function, you have another function, which is an exponential function, which is e raised to x. So yeah, it's intimidating. But don't get me wrong, guys. I can simplify this one. All right. Before I do chain rule or what or product rule, I think it's better to simplify it first. All right. First and foremost, let's focus on this one. Sine squared x plus cosine squared x is equal to 1. Okay, this is one of the trigonometric identities used, all right, used in basically verifying, simplifying a trigonometric equation or an expression, all right? Specifically, this is one of the Pythagorean identities in trigonometry, all right? Next, you have ln of e raised to x. So this just equals to x. And how does this happen? Is this just basically based on the rules, based on the law, or what? Yes, it is actually based on the law, but what do you call this one? But however, it's an application of laws of logarithms, not basically only the application of one law. All right. What I mean is that um, this one, the answer is x, and basically I base it with the laws of logarithms. So that means not only I use one law of logarithms, but I use more than two laws of logarithms. So let's introduce ourselves first so that you may get it, right? So you have log base b, and then you have your x. Log base b of x is equals to your y, right? Your y, that would be your exponent, and your x, that would be your argument or your answer. Because if you're going to convert it in an exponential equation, you'll have b raised to y is equals to x. All right. This is the exponential equation. All right. But this one is a logarithmic equation. Don't get me wrong. But yeah. All right. So that's it. So here's the first law I used. All right. First law is that if, let's just say, yeah, log base b of x, and you have an exponent of 2, all right, this is just the same as 2 times log base b of x, all right? Basically, what I just did here is that I bring down the exponent, all right? So I'll have 2 times log base b of x. That's it, all right? I just bring down the exponent. So this is what you call as the power rule, all right? The second law I used here is if you have the same argument as your base, basically the argument is the same as your base, this is equal to 1, all right? So for example, if I have log base 3 of 3, this is just the same as 1. Sorry. This is just the same as 1. Right? So that's it. Okay. And here's the third rule. All right. So what if my base is not b, rather it's e, right? Log base e of x. This is just the same as ln of x. All right, this is just ln of x. Because log base e of x is just the same as ln of x. So let's try that here. All right. So ln of e raised to x. Okay. Since x is your exponent, I'll bring it down here. So I'll have x times ln of e with the definition, based on the definition of the power rule, one of the laws of logarithm, right? Number 2, this one, all right, you have ln of e. Your e is the argument. So I can convert this one into a logarithmic form. So this is x times log of base e of e. Overall, here is the argument here, right? And then the base of the natural logarithm is e. So you have this one as, as to rewrite it in a logarithmic form. And now last but not the least, since your base and your argument is equal, or are equal, I mean, so that means this is equal to 1. So this is x times 1. So you have x. And there we go. That's it. So we can erase it. So to rewrite it differently, right? Since sine squared x plus cosine squared x is equals to 1, therefore this would be 5 times e raised to 1, or just simply 5 times e. Right? It's up to you if you're going to put 1 as your exponent. Next here, since ln of e raised to x equals to x, therefore this will be substituted as x instead. Now let's get the derivative for this one. 5 times e. How can we get a derivative for this one? Can I use chain rule? You could. Product rule? You could as well. But for me, I'm not going to do that. I'm going to apply here is constant rule of differentiation. Is it, what do you call this one? Is it like this one? Like the derivative of c times f of x, which is equal to c times the derivative of f of x? Or is it this one, the derivative of a constant term, right? So which one I'm going to use here? Which one? All right, this one actually. Why? Right? Why and how? All right. All right. Yeah, constant rule of differentiation. Specifically, if you're going to derive a constant term. So 5 is a constant term, yes, and your e is already a constant term. Or let's just say e is what? A constant term. All right. So why is that happening? Or how does that happen? So take a look at this way, right? When you say e raised to 1, this is already equal to 2.71 and so on and so forth. And many more decimal values to exist. So as you can see, this is just similar as your pi. All right, this is just similar as your pi. It's continuous. The decimal values are yes existing continuously. All right. So as you can see, this is an irrational number. So if it's e raised to x, yeah, that's a function. But if it's e raised to a constant number, it could be e raised to 2, e raised to 3, e raised to 1, just like this. That is already a different scenario, all right? Because if you're going to get the derivative of e raised to x, this is simply as e raised to x. But if you get the derivative of e raised to 1, or let's just say e raised to 1, or e is just the same. So this is just the same as getting the derivative of 2.71 and so on and so forth. So the derivative for that number is 0. because basically, like, if you're going to input a number here as your input, the result would be a constant number, and therefore getting the derivative of a constant number is equal to 0. All right, it's equal to 0, right? So that means getting the derivative of a function is not equal to getting the derivative of a function in which its input is given. All right, and the input is a constant number, because if you're going to substitute a constant number or a constant number inside of your x, could be e raised to 1, e raised to -1, e raised to 2, or e raised to 0, and so on and so forth, the answer would be 1, a constant number. Thus, the derivative of a constant number is equal to 0. All right, and a derivative of a function is this one. So therefore, they are not the same. So you have 0. And in here, the derivative of x, just simply remove the x and you have 1. Therefore, you have 1 as your final answer. And that's it, guys. That's all. All right. Forgive me if the way how I talk is complicated in a way. Don't worry, guys. Be honest in the comments. Like, do you at least understand on what I'm trying to explain, what I'm trying to discuss, or what I'm trying to basically, give out some points? So, yeah, forgive me because I am not actually used to speak English fluently a lot. I am used to explain two languages at the same time, okay, which is Tagalog and English. I'm doing my best to be good at English because I'm just trying to help other people from the other countries. And forgive me if I don't literally speak English in a simple yet fluent manner, right? Because what I did is like a combination of simplicity and complications. Forgive me, all right? So that is all. That's all I can say. Don't worry, I'm doing my best to improve it. All right. So thank you for joining me in answering this exercise. Once again, I am Math Angel Faith, and I'm always here to guide you in answering mathematics. See you.